What's up, you freaking geniuses? So in this video, I'm going to teach you how to factor trinomials that have a leading coefficient of 1. Okay, and more specifically, these are quadratics that have a leading coefficient of 1. So right here, as you can see, there's no number, so that always means there's just basically a hidden 1 right there, right? And same thing with the rest of these problems. They all have a coefficient of 1. Okay, and there's basically 4 different types of problems you're going to run into when you're doing these types of problems, and it just has to do with the signs. So this first example, as you can see, it has a plus plus. This one has a minus plus. This one has a plus minus, right? So it's just flipped. And then this last one has a minus minus. All right, so I'm going to do an example of each one so you know how to solve each case. All right, so let's start with this first one right here. So here we have x squared plus 7x plus 12. So first of all, you need to find two numbers that multiply to this number right here at the end, okay? Positive 12. And the other thing those numbers have to do is add up to this middle number right here, positive 7. But you always want to start with your multiplication right here, okay? So first of all, let's find two numbers that multiply to positive 12. So that would be 1 and 12. That would be 2 times 6. That would be 3 times 4. And that's it, okay? Those are all the numbers we can multiply together to get positive 12. Now we just have to figure out which one of these pairs right here add up to positive 7, okay? So 1 plus 12, that's equal to 13, right? So that's not it. 2 plus 6, that's equal to 8, so that's not it either. Well, what about this one? 3 plus 4, that's equal to 7, right? Positive 7. All right, so that means the two numbers we're going to use when we factor this out are positive 3 and positive 4, okay? So in order to factor this, you're just going to write out your two parentheses right here, right? And then since we have an x squared right here, that means, and right, it has a leading coefficient of just 1, so that means we're going to put an x here and an x here, okay? And again, what goes here? Well, the two numbers we just found, positive 3 and positive 4. Okay, so positive 3, so plus 3, and positive 4, so plus 4, okay? So then this would be your factored answer, x plus 3 in parentheses times x plus 4 in parentheses, okay? Now, if you want to check your answer to see if this is actually correct, all you have to do is FOIL this, right? And you should wind up right back where you started. You should get x squared plus 7x plus 12 when you FOIL it, right? So if you want to check it, we can do that really quick. So if we FOIL this, let's do first, so x times x is x squared, then outer, so x times positive 4 would be positive 4x, right? So plus 4x. And then inner, right? So positive 3 times x is positive 3x, so plus 3x. And last right there, so positive 3 times positive 4, that is positive 12, right? So plus 12, right? So if we simplify this, we're going to have x squared, and then here we have plus 4x plus 3x. That reduces down to positive 7x, right? So plus 7x, and then positive 12 at the end. Okay, so as you can see, we winded up back to exactly where we started from, right? X squared plus 7x plus 12, x squared plus 7x plus 12, right? So that means we factored this correctly, right? So this, again, would be your answer, x plus 3, x plus 4. Okay, so not too bad, right? Let's go to this next example right here. So t squared minus 11t plus 28. Okay, so again, we need to find two numbers that multiply to this last number right here, so positive 28, and it has to add up to this middle number right here, negative 11, all right? So first of all, again, let's find two numbers that multiply to this last number right here, positive 28. So we have 1 times 28, we have 2 times 14, and 4 and 7, right? 4 times 7. So are these all of our pairs? No, they're not, okay? Because remember, when you multiply two negative numbers together, they equal a positive number, right? So I can attach basically a negative sign to all of these numbers, and they would all still equal positive 28, right? So negative 1 times negative 28 is also equal to positive 28, right? Negative 2 times negative 14, that's equal to positive 28. And negative 4 times negative 7 is equal to positive 28. Okay, and one thing I want to quickly point out is when I was figuring out those pairs over here, I could have done the same thing over here, right? I could have attached negative signs to all of these, okay? But I didn't have to do it in this first example because both of my signs right here, I had a plus there and I had a plus there, okay? So that means all the numbers I'm going to be working with in my problem here, they were all going to be positive anyways, all right? So I don't have to deal with negative numbers. Okay, but here in the second example, as you can see, we have a negative sign. Okay, so if you ever have a negative sign in your problem right here, make sure you take into account your negative numbers also. Okay, so we found all our pairs that multiply to positive 28, right? So now we need to figure out which one of them add up to negative 11. Okay, so starting at the top, 1 plus 28, that's equal to 29. 2 plus 14, that's equal to 16. 4 plus 7, that's equal to 11, okay? But I'm looking for negative 11, right? This one is positive 11, right? But I'm looking for negative 11, right? So it's definitely not this one, okay? And then here we have negative 1 plus negative 28, which is the same thing as just negative 1 minus 28, so that's negative 29. Then here we have negative 2 minus 14, that's negative 16. And then here we have negative 4 minus 7, which is equal to negative 11, okay? So the two numbers I want to use in my factored answer are going to be negative 4 and negative 7. So then here, I'm just going to write my parentheses, okay? And in this case, we have a t squared, so that means I'm going to have a t here and a t here. And then again, I'm going to use negative 4 and negative 7, right? So minus 4 and minus 7. Okay, so then this would be your factored answer. And again, if you wanted to check it, you could simply FOIL it, but you would find that we would just wind up exactly back where we started to, right here. Now let's go to this third example right here. So h squared plus 4h minus 12. So again, the first thing I want to do is find two numbers that multiply to this last number right here. Make sure you always take into account the sign, okay? So we want two numbers that multiply to negative 12, right? The sign right there is negative, so negative 12. And it has to add up to this number right here, positive 4, okay? So first of all, let's find two numbers that multiply to negative 12. Well, in order to get a negative number, one of my numbers are going to have to be negative and the other one has to be positive, right? So something like negative 1 times positive 12, right? That's equal to negative 12. But I could also flip it. I could write it as positive 1 times negative 12. That's also equal to negative 12. Okay, we can also do negative 2 times 6, or we could do positive 2 times negative 6. And lastly, we could do negative 3 times positive 4, or positive 3 times negative 4. Okay, so cool. We found all our pairs right here that multiply to negative 12. Now we just need to figure out which one adds up to this number right here, positive 4. Okay, so the two that add up to positive 4 looks like it might be this one, right? Negative 2 plus 6 is equal to positive 4. Okay, so the two numbers we're going to use for our factored answer are going to be negative 2 and positive 6. All right, so let's draw our parentheses right there. Here we have an h squared, so that means I'm going to have an h there and an h there. And then again, I'm going to use negative 2 and positive 6, right? Negative 2 and positive 6. Okay, so again, this would be your factored answer, and if you want to check it, you would just have to FOIL it, but you would find, again, that we just wind up right back where we started from, so we know we did it right, okay? Now let's do this last problem right here. R squared minus 3r minus 40. Okay, so again, we have to figure out or find two numbers that multiply to negative 40, and they have to add up to negative 3, right? They have to have a difference of 3, negative 3, right? So first of all, two numbers that multiply to negative 40 would be 1 and 40, 2 and 20, 4 and 10, and 5 and 8, all right? Those are all the pairs right there. Okay, but again, this is a negative 40, so that means I need to slap a negative sign on one of the numbers in each of these pairs right here. Okay, but keep in mind, these pairs right here also have to have a difference of just 3 right here, right? They have to add up to negative 3, right? So 1 and 40, there's no way I could add these up. Doesn't matter which one has a negative sign. there's no way I can add these up to get anywhere near just a difference of 3, right? Same thing for 2 and 20 and 4 and 10. But 5 and 8 right here, these have a difference of 3, okay? But remember, one of these numbers have to have a negative sign on them. So I'm either going to have it as negative 5 times 8 or positive 5 times negative 8. Okay, so which of these two pairs right here add up to negative 3? Well, negative 5 plus 8, that's equal to positive 3, and 5 plus negative 8 is equal to negative 3, right? So this is the pair I'm going to use down here. So I'm going to have a positive 5 and a negative 8, okay? So again, I'm going to draw my parentheses right here. And in this case, we have an r squared. So we're going to draw or write an r right there and an r right there. And then again, we have a positive 5 and a negative 8. So I'm going to put positive 5 and negative 8, right? So then that would be your answer right there. So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below. Also, there's a couple playlists attached that I think you'll find helpful, so definitely check those out, and I'll see you there.